Hello everyone and a very good evening to all of you. I hope you all are safe, healthy and taking a very good care of yourself. Although our life is coming back to normalcy, but yes, we definitely need to follow the protocols to keep us safe and sound. I, Dr. Subhendu Chakravarti from the School of Sciences, Oro University, would like to welcome you all on today's webinar entitled Necessity of Higher Education and Scientific Research in India. Let me first give a brief introduction about Oro University and School of Sciences. Oro University was founded in the year 2011 by the Rama family and is established under the Gujarat State Private University Act 2009 and is approved under Section 2F and 22 of the UGC Act. Oro University works on the teaching and philosophy of Sri Aurobindo and Divine Mother. In School of Science, Oro University, we have undergraduate honors course for 3 years in chemistry, physics, mathematics, zoology, botany and microbiology. Now, let me introduce our today's speaker. I extend my warm welcome, sir, to Professor Somaditya Sen. Professor Sen is an associate professor in the physics department at the Indian Institute of Technology, Indore. He is also serving as an adjunct associate professor at the Ming Chi University of Technology, Taiwan, and a consulting associate professor at the Department of Physics in King Fahd University of Petroleum and Minerals, Saudi Arabia. He did his PhD from Jadavpur University and Indian Association for the Cultivation of Science, Kolkata. Thereafter, he served as a postdoctoral fellow and research associate in different international universities, such as the National Taiwan University, Taiwan, the University of Electrocommunication, Japan, and the University of Wisconsin, Milwaukee, USA. He joined IIT Indore in 2013 as an associate professor, and due to his strong commitment towards the development of this institute, he served as a member of the board of governors of the institute. He developed of this institute. He played an important role in the growth of IIT Indore and also served as a dean planning, acting and associate. Academically, he has published more than 122 publications with a citation of 1071 and an H index of 18. He presently leads a very active team of researchers consisting of doctoral, master and bachelor students involved in different projects related to material science and electric or electronic engineering. Now I would request Professor Sen to make the opening remarks and take over the session. Sir, you unmute yourself.
Oh, sorry. Thanks everyone for just one minute. So just give me 1 second. Thanks everyone for being part of this talk today. I'm Dr. Somaditya Sen. I'll just share my screen at this moment. Just 1 moment. Okay. So thanks to Oro University for giving me this opportunity to talk about the necessity of higher education and scientific research in India. This is Dr. Somaditya Sen from IIT Indore, and today I'll guide you through this topic, which I feel is very much important at this present stage. Now, to begin this talk, I will take you to the social scenario of science in India. Okay. Right from the very beginning, there were different talks about what science is and how science can be a ghost in one's mind, talking about it invades someone and makes them really crazy and other things. Okay. Obviously, there are ghosts in science, like Ghost Nebula. The European Space Agency has provided these pictures, photographs, which gives us knowledge about different galaxies, a collection of clusters and other things. Now, but the important thing is science is important for humankind. Yeah, scientists are mad. They spend hours in their laboratories. They do weird things to go through the newer innovations that has carried humankind so far. And there's a myth also that scientists are scientists if only they have the mad hair and beard. Okay. Jokes apart, let's look at some of the big scientists like Charles Darwin, and the modern evolution theory came from him. Dmitri Mendeleev, periodic tables. Albert Einstein, well, I should not say much about him because he's all-knowing benefactor. So where do I stop his description? Professor Sir Martin Cherenkov is one of the pioneers in chemistry of today's scientific world. So all of them had certain peculiarities, right? Let me tell you about one story which involves my life, right? Now, when I was doing my PhD, I was doing my PhD on semiconducting glasses. Now, glasses, as you know, these are amorphous materials which are generally non-conducting in nature. Now, semiconducting means they have some conducting properties. So my job was to find out the structural properties and the electrical properties of these glasses. Now, it happens so that I had a favorite chashma wala, means a specs person who used to make my specs ever since I was in class 5, and I continued to make specs from him until my PhD. During my PhD, I was teaching his son physics, and one fine day when I was teaching his son, he came up to me and he asked me, what do you do research on? And I said, I make glasses. And he became very excited. You make glasses. Okay. So what good are these glasses for? Then I said, okay, these are semiconducting glasses which can make new devices. And for some period of time, he became speechless. And then he said, samajh gaya. Sab bakwas hai. You take public money and mix A and B and C and tell useless stories, which does not come to any help to India. I was stunned. Actually, I do not know what to answer at that moment. But next Sunday, I took 2 glasses. One was photochromatic and the other one was normal, both of which were handed to me. And I demonstrated to his son that the photochromatic glass took a longer time to burn a piece of paper, and explained how the properties of the glasses can be changed by mixing something and other things, okay? And I also described the mechanism of that. So that created some interest in the chashma wala, and I'm very happy to say that this chashma wala's son pursued a scientific career. Anyway, jokes apart, let us come to the main point. Science is everywhere, starting from the laws of physics to chemical reactions to the formation of new materials using the chemicals, and to find new functional properties from these new materials. Now, these functional properties from new materials can be used in various types of devices, and these devices can be used to attain new heights in technology. So we are dependent on science in everything. Now, let us come to a bigger aspect, okay? So let us take the example of country. We know each country has its own economy, and the people have to go through the different economical conditions throughout the world. But the country's economy cannot be elevated without the scientific progress and upliftment of the educational standards of the country. What makes a country a superpower is investment in different aspects of science and technology. Atomic energy, space research, latest warfare, agricultural support, and basic cutting-edge research in science labs. These has to be addressed by a country's surviving government and the people. There are numerous examples. What scientific progress, deprivation of scientific progress can do to destroy a country's economy. This picture is from Africa. This is also Africa. These are some parts of Africa and Asia, and this is Afghanistan. More than half of the urban dwellers, not village, urban dwellers of this country lives in slums. And that's because they have not been able to uplift their scientific scenario. Just look at the difference between a first world country classroom. This is USA, this is Germany, and this is our favorite India, our country. It's very disheartening to see our children still have to suffer in the villages with lack of proper facilities that makes them sometimes bored about education, and we are not being able to concentrate on that issue in the proper way. Education has to be made interesting so that we can put our mind into bigger things. See the facility, change difference of facility that we face. This is a first world country, a US school bus, totally air conditioned. Children are from, these are general children, not very high profile children. High profile children do not go to the public school in US. And look at this bag rack here and what our children has to face. They have to treat their bags as their desks. They have to walk miles using their, or they have to bike for miles, cross rivers to reach school every day. Now, while saying all this, can we change on this? Yes, we can. These are pictures from China, our neighboring country, China. In 1980, this was the scenario. And in 1990, they had improved a little. And by 2020, they have changed. Is this magic? No, it's not magic. It all came from the hard work and well-planned decisions made by the Chinese people. Now, each country had to go through their own industrial revolution. Industrial revolution started in Europe in the 1700s, late 1700s and 1800s. And it continued to happen all throughout history ever since then. And in 1900s, we saw a huge industrial revolution. However, India failed to generate its own industrial revolution due to lack of mass-scale higher education and scientific aptitude. This we have to agree today and take measures to move forward. The world has so far seen 4 different industrial revolutions. The first revolution was about the steam power, steam engines and machinery related to using steam power. The second revolution, the first revolution was back in the late 1700s to late 1800s. Now the second revolution came as a mass production of various things, equipments and other things, and the generation of electricity and using it to uplift our technological. Now the third revolution was about the electronics development and IT systems. This is about 20 to 30 years back that started, and it quickly transformed to a fourth revolution, which is the cyber physical system, using Wi-Fi and interconnectivity of different things. Now, India did see the first industrial revolution from the 1770s to 1850s, but not as a participant in the industrial revolution independently, but as a source of cheap labor to Great Britain. Unfortunately, India has fallen behind the rest of the world, first world countries. But there's a good news. The good news is we are gradually pulling up. We are gradually pulling up to a position where we can now compete with the bigger nations. But are we doing enough? That is the question that we will try to answer. The world is changing fast and super fast. That is what we have observed in the last few years. Technologies have changed. Mobile phones, gadgets, different gadgets that we use today. And numerous examples of innovations are coming up that the world is seeing every day. I'll uphold some of these applications that we are using today. Now, I, being a diabetic patient, I have to prick my fingers to check my blood sugar every day, maybe 2 or 3 times. Now, then I have to take the injection, insulin. So it takes a lot of pain, right? It's not that easy to prick fingers day and night. Now, we can see that in Germany, they have discovered a sensor which can be put on your skin, and you can swipe this freestyle liver sensor gadget, and you can have your blood sugars accordingly. And then you are obviously still now you are using insulin injections, but maybe someday we will not need an injection at all. Another good example which always invades my mind is, what if we can control our computers, tablets, and TVs just by sight, without the use of mobile phone, remote controls, or a keypad or a mouse, just by eyes? Yeah, this is already there for some physically disabled people. It's already in use. It's called entertainment by sight. And then there are some examples like the smart can. It has a microphone, it has a speaker, it has a sensor, ultrasonic sensor, which can see what is around and tell the person where to go and which direction to go. And then there's a smart chair which has come up recently, and it can go up and down a staircase. Amazing, isn't it? Now you might be asking, sir, why are you talking about these things which can only help physically disabled or challenged people? Actually, I say nobody is physically disabled. Everyone has his capacity of giving. The greatest example is Professor Stephen Hawking. We all know him for his Big Bang theory, right? He was an English theoretician physicist, a cosmologist, an author. And you will be amazed to hear about his life. At age 23, he suffered from motor neuron disease, which made him more or less paralyzed. Then in 1985, when he was 43, he developed pneumonia and he was put on a ventilator. Then, at a very critical situation, the doctors thought he will die. His wife resisted, and ultimately he was put on tracheotomy. And the tracheotomy generally uses a hole which is made in his neck, and a tube is placed which goes directly to his lungs through a windpipe. And for that, Professor Hawking irreversibly lost the ability to speak. That did not take away his contributions to science. For the next 33 years, he did a lot which can give to science, right? Now, was his life very monotonous? It was not. He did make a lot of good experiences in life. The zero gravity experience, where a flight was taken at 45 degree up and then 45 degree low down. And during this transition, there was a feeling of zero gravity. This zero gravity is a feeling of levitation, which we have seen is a mind-boggling thing in human society for a long time. And there are tricks of levitation. But levitation is not a trick in science. Superconductors can levitate. Okay, the superconductors are a group of materials which can conduct electricity without any electrical loss. That means they have zero resistance below a certain temperature. Superconductors does not allow magnetic lines of force to enter the material. Now, there is something called Messner Effect, which describes this effect. And you can see that magnetic lines of force do not enter the superconductor, and it cradles the superconductor above the magnet. Now, the magnetic lines of force cannot penetrate the superconducting materials. That this concept can give rise to a very interesting feature. You can glide this superconductor through on a magnetic rail. So just think about a car which can float without friction and move ahead on a magnetic track like this. There are other materials which are also very important. There are numerous materials. I'll talk about a few. Carbon nanotubes. They are a complex network of carbon atoms rolled into a tube-like structure, and they are hexagonally attached to each other. And these carbon nanotubes nowadays are being researched to be used to replace silicon in electronic devices. Now, one recent work came up in UW Madison. They made a CNT transistor out of a very thin layer of CNT. There are other examples where materials have coupled up with electrical engineering, mechanical engineering to provide newer solutions like battery cars, solar cars, and other things. Energy is a big problem of today, and energy now can be harvested from water. Just think about 30 years back. Who could have ever expected that we could generate energy from water? Yes, water can be decomposed into hydrogen and oxygen, and they can be allowed to react, and the electronic exchange between these two gases can generate a current and generate a voltage. These are called hydrogen fuel cells, and one of the greatest examples is solid oxide fuel cells. The solid oxide fuel cells use the same principle and is currently being used in USA and some ships to provide electrical energy. Talking about life science, conventional vaccines are really painful, right? Any alternative? Let's reverse this process. We do not need these needles anymore. Can we have patches, nice stickers, so that the required medicine can flow through the skin to our body? Yes, Germany has already made this thing. Now, we all know that cancer is a big problem to us, big problem to humanity. Bone marrow transplant sometimes seems to be the only solution, which requires stem cells being collected from bone marrows. But now, with recent development in technology, we can extract the stem cells from blood, just normal blood, and transfer it to the required person. Cybernetic implants. An old example is a coronary pacemaker, right? Cybernetic implants are very necessary in our present day. I'll take my example, my problems example. I am a diabetic. Suppose we have a pump which also has a blood count instrument inbuilt. So you can count your glucose level through a glucose sensor. It's a continuous glucose sensor, so you can continuously monitor your blood sugar level, and whenever the counts go beyond a certain level, there is a input of insulin from the pump, keeping your insulin level at par. Now just imagine this can be also provided to cancer patients. Okay. Now, cancer patients frequently require something like chemotherapy or something like that. But often the doctors give an estimate depending on their judgment, and so the counts are dynamic, right? So the blood counts are dynamic; they can change, and depending on that, sometimes the counts of maybe the white blood cells have gone down very less, and still we are giving an amount of chemotherapy which can be fatal. The counts can go yet further. So this incidents will not happen if we continuously monitor and continuously add a proportionate amount of chemotherapy. Now, 3D printing of body organs. This is a very new technology. 3D printing has come into existence for the last 10 years. How will it be if we can print our body organs like the parts of the heart, parts of the human skin, and replace a damaged part of our body? Amazing. Tattoos. Some of us are very excited about tattoos, right? Now, how will it be if a tattoo can be an implant itself on your skin, and that implant can generate a signal which can be transferred to your health provider, and the health provider will get an update of your health condition when you are in the mood. And immediately you get a call from the health provider, hey, you're running a fever, you should take this medicine, or you should take rest. Or your blood pressure is going high, please take this medication. That's amazing, right? So these are already in the move, and we can see these are realistic implants that are being made. Now, we all suffer from the problems with our gadgets and the problems with charging them. Can we say goodbye to these wares and adapt a new inductive power transfer technology which uses EM waves and can transfer the energy from one building to another, one spot to another? It is possible, most probably, but maybe it's not that near, but we can charge some of our equipments at least using these technologies. And what more, this may not require any battery, so we do not need to replace our batteries. Now, some innovative ideas are already on the run. Some are like the smart watch, smart telephone, some smart clocks, smart screens, smart calendars, and then we have other smart ideas like smart projectors, smart tabletops, and then smart newspapers, magazines, and smart window panes. This is the very interesting thing. You can go to your window and do your computer work. Now, electromagnetic signaling and computer-controlled mechanical engineering has already given us the flavor of a probable autopilot car. The autopilot car can sense different objects, different signals, different notifications ahead, and they can judge which way to go. Now, these require different components of different technologies. Nowadays, you must have heard about artificial intelligence, which uses a huge set of tools for making computers behave intelligently. Now, this is the most transformative technology of our times. Okay, it improves customer experience, streamlines business, and enables us to realistically predict different aspects of science, technology, and business. It is a little expensive at this moment, but we know that it will transform the way we do everything. Okay? So life ahead is not the same life that we lead today. And what more, it brings interdisciplinarity at its maximum. Machine learning, it's a field, it's very similar, field of study that gives computers the ability to learn without being explicitly programmed. Now, it involves computers learning different patterns from a given data, applying it to the new data to make predictions. It can predict whether an email is spam or not. It can predict whether a customer is burning out. He may be frustrated on you, right? Or he may be happy, okay, by judging his temperaments. And most importantly, it can judge a medical image. You don't have to really wait for your about your medical report. You have the image, you can judge it. Now, all this will need endless storage. Now, where from will this storage come from? Our material scientists are hands-on with our electrical engineer, electronics engineers, and nanomaterials are being used to devise different devices for large-scale storage. Now we see, I hope I have been able to emphasize on the fact that we are standing today in front of a new era, which means very much an interdisciplinary scenario. It is a complex network which is gradually giving rise to a new industrial revolution. It will encompass biology, chemistry, physics, engineering, management, humanities, and every sector. Yes, humanities, social sciences, psychology, cognitive sciences, everything will come into this domain. And to be really true to you, the most exciting research is happening at the interface of these disciplines. It is no longer on hardcore biology or chemistry or physics or humanities or management. It is at the interface of these disciplines. And we are seeing this every day. So again, I want to say the world is changing super fast. The world is about to see the biggest and life-transforming industrial revolution ahead. But are we prepared? Now let us see at what our Indian system is doing. In this year's Union budget, the government has declared a 8,000 crore budget for the next 5 years on a very cutting-edge subject called quantum technology. This involves every sector of science and is the solution ahead. This is very encouraging, and it is encouraging to see that we are investing more and more on science and education. Now, India spends about 3.2% on education and 1.1% on science. 10% of the budget goes to defense, approximately, and it's not the right exact amount. Okay, now why I talked about defense, I am coming to that. Now let's see what the other countries are doing. Germany spends a 5.1% on education and science. USA spends 6.5%. I want to get your attention here on the amount of defense budget that they have. 54.5% of the entire budget. It's more than 50%. United Kingdom spends about 12%. Israel, 15%. France, 33% on education and research. It's a very important message. Now let's look at the US budget. The defense, having 54.5% of the total budget, spends about 11.7% of the defense budget on R&D, means research and development. So that if you do the mathematics, it's about 6.5% of the total budget that is going for in defense-related research and development. And mind you, this research and development of the defense budget is not actually to make arms and other things only. It also goes for science, hardcore science, because they know that these scientific experiments and results will be necessary for the development of the defense components. Hence, we have to put our attention to what we are doing on our part. Where are we placed in the military expenditure of, when compared to other countries? We're not doing that bad. We are about 4th or 5th actually, compared to other nations. United States, obviously far ahead. China next, Saudi Arabia, Russia, and then India. So we are doing quite well here. But DRDO, the research component of our defense budget, is only 6.3%. That means that if you do the mathematics, it's about 0.63% of the total budget goes to defense-related research and development, which is not that great. So we have to improve it. So I hope that by this time, I have been able to make it clear that innovation is no longer an option. It's a necessity for humankind, a necessity for survival. And for India, and for every country actually, and for humankind, it's higher education and scientific research is a necessity. Who else can? Mr. COVID-19 can teach us better. We have all seen in the last few months what we had to go through and where we can lead to if we do not pay attention to science and higher education. Now, there's a myth that often is said in our countries like us: if you do science, you do not have a prospect of a good prospect. And most science careers go to different other things. But yeah, I differ. I fail to agree on this thing, because there are lots of jobs which are related to science. Environmental scientists, forensic scientists, biochemists, biophysics chemists, and lots more. In fact, if you look at it, apart from hardcore science-related careers, you can also have a lot of different avenues where science background people are needed to express their components of these different directions, like writing, like communication, illustrations, administration, journalism, anything you talk about in these things, right? So you have a science career and you can lead to any one of these careers. Just one example, what individual subjects can provide you. I have taken the example of chemistry and life science because I got very nice images from the internet. So yes, just look at the number of possibilities that you can have pursuing a science major or something like that. The no talk is complete without the discussion or without looking into the depths of lives that are related to the field. Well, in this talk, I'll just talk about 4 scientists. Michael Faraday. He is well known for his electromagnetic induction theory and the fast experimental correlation between light and magnetism, benzene. First room temperature liquefaction of a gas was all performed by this scientist. His name will be there forever long, because he has contributed the most important things that we are standing on. Even today we talk about electromagnetic radiation, it was from Michael Faraday. But Michael Faraday was not from a rich family. He had a very difficult past. At the age of 13, he was working as a delivery boy. His father was sick, so he could not afford to run the family properly, so he had to work. Then he took up an apprentice job in a bookbinder shop, and that really changed his life. So while he was binding books, he came upon science books and he went through them and he got fascinated to science. He attended a lecture by the famous chemist of those times, Sir Humphrey Davy, and he was so excited that he wrote up the lecture and wrote it. When he came back, he wrote it in his handwriting, bound it, and sent it to Davy. Davy later took him as a scientific assistant and secretary, but due to his origins, poor origins, he was not looked up by his Devi's wife, who was from an upper class. He was always looked down. But that did not stop him to do this, to go through this scientific innovations. So science does not need backing; it just needs your good intentions. Sir Alfred Nobel. Everybody of us, we at least know what a Nobel Prize is. Do we know that the Nobel Prize comes from an enormous gift that was given by Sir Alfred Nobel? 90% of his enormous fortune that he made from explosives was donated to fund the Nobel Prizes. He invented dynamite, and that's how he became rich. But he was born in a penniless family, and the family was so poor that he fell sick repeatedly, and that ill health that he generated when he was young followed him throughout his life. And those of us who think that we did not get proper education in a proper school and we had to go to a very backward school, that's not correct. That's not correct, because Sir Alfred Nobel, went to a school which was for impoverished children, poor children. Now we'll come to the life of Srinivasa Ramanujan. We are very unfortunate that he died at a very young age, at the age of 32, and due to probably liver parasite infection. But within that short span of life, he produced almost 4,000 proofs, identities, conjectures, and equations in pure mathematics. His theta function is still has given rise to is in the heart of string theory. But he too was from a very poor family. As a teenager, he used to do a lot of mathematics, but he did not have the papers to write it down on. So he used the temple floors to write with chalk and dust. The last example that I'll give is our favorite ex-president of India, Dr. P.J. Abdul Kalam. Now, he was also from a very poor family. He had to sell newspapers to support his family. And we all know what he did for India. Now, he graduated in physics in 1954, then joined aerospace engineering in 1960, joined as a scientist in DRDO, and later worked with Dr. Vikram Sarabhai and participated in the launch of Rohini satellite. Then he got his job in ISRO, and from 1965, he had his own independent project, with which from 1970 to 1990, he produced very important projects which helped India attain this position today. PSLV, SLV-3, Project Devil, Project Valiant are some good examples. Then he was the chief executive of the Integrated Guided Missiles Development Program, and Agni and Prithvi are the two great achievements that India can boast of today. He became the scientific advisor to PM and was the secretary of DRDO from 1992 to 1999. The Pokhran 2 nuclear tests were conducted under his leadership, and he is the most well-known nuclear scientist of India. See, the greatness of a big scientist is he did not restrict himself to this arena only. He also took part in the invention of a low-cost coronary stent, which is required for heart problems. And this stent is known as Kalam Raju stent. This he developed with cardiologist Soma Raju. So a scientist should be interdisciplinary at heart. It is a great fortunate episode in my life that I could interact with him for a short span of time. And who else can I thank for this rather than science. It's only because of science I could meet such big people. To come to the end of my talk, I admit that science really needs 24/7, or rather 24/365 days a year effort from us. It's tiring, but we still strive to do science. It's madness, and we are sort of abnormal people in that way. But believe me, at the end of the day, it's so rewarding. It's very rewarding. And although I admit that we are a different category than normal people, but we still have our normal components. We are like normal people. We go on excursions, we celebrate birthdays, we celebrate our graduations. And yes, my chashma wala, revered chashma wala, he will be happy. We do not celebrate from a public money, it is from our own pocket. Now, this is my part of my group. It's a small part. Actually, the group is much more clear. And these are my pictures, with and without beard. Science is carried forward by mad people, mad scientists like us. And I think we are the critical thinking network that the world needs to move ahead. I would like to thank the Oro University for sponsoring this talk. Thanks to the Honorable Founder President, Sri H.P. Ramaji, Dr. Rajan Velukar, Vice Chancellor, Dr. Rohit Singh, Dean Academics, Mr. Ajay Kumar Yadav, Registrar, the Faculty of School of Sciences, IT team of Oro University. And I'd like to thank IIT Indore also for letting me give this talk. And last but not the least, a message to all of you. Please remember that science is everywhere. So for our beloved country and for humanity, please go for higher studies, think science, eat and drink science, live with science. And thank you for patiently listening to my talk.
Okay.
Thank you, Professor, for inspiring the students and the viewers. It is a very
Thank you.
And I am speechless because it is very outstanding presentation and time and effort you have given to share your thoughts and knowledge. Now I would like the students or the viewers who can ask any questions, they can go for that.
Okay. So should I stop sharing?
Yeah, you can.
Yeah. Yes.
You can see the QA question. You can see also the QA questions if it's coming. QA.
Really, I don't. Okay, yeah. I can see. Ankita Datta, investor. Nice investment. Yeah, but I don't see questions. Is there anyone to ask questions? I think they have to unmute and. Okay, I don't think I am seeing any question here. Okay.
Sir, there is a question and answer session. Section.
Okay.
So from where you have shared your screen, there are options called participants, Q&A.
Okay.
So you have to click Q&A. There are 8 questions.
Okay.
Okay, there are 8. Can I help you, sir? There are 8
Yeah,
questions.
please.
Yeah.
Right.
Yeah, I'll try to read the questions. If you, yeah. So the first question is something from, say, I don't know the name, but it's written Redmi. But it's written like, why are there so much less job opportunities for people having doctoral degrees, even though there is so much necessity for higher education? So this is
Yes. Okay. So I should not blame it on any sector, but when a person tries to get to a position, the thing comes very gradually. It does not transit all of a sudden, right? We all know this. So a progress of a nation is also something like that. Okay, so we have to pass through this uh, tenure where we have to understand that the country is struggling to create more jobs which can relate to science. Okay, so already we have seen some good efforts from the government, and some new institutions have come up, some new research and development organizations have come up, some private organizations are coming up also. So in near future, I believe we'll have a much better scenario. But also we need to understand that we have to educate the mass in science. That is more important. And it is very important that today we take up the venture of qualifying each and every layman with minimum knowledge of science to understand the necessity of understanding the logics and not go into just taboos that exist in our society. Yep. Can I take the next question? Yeah.
Anonymous entered me. Do you think there is anything allied institution like IITs can do to encourage more students to go for higher education in India?
Absolutely. Like institutions like IIT always has extended their hands to even school level or pre-college level students, and I think it should be done in a more large scale so that the general education system gets the maximum support from these highly qualified and highly equipped institutions of India, so that they can become more educated in science and technology.
Another question from Santosh Paul. Could you see a possibility of lower quality of education if more online learning instead of classroom teaching in the future?
That's a very interesting question, contemporary question. Yeah, I think I should not comment on this at this present moment, but when the question has been risen, I should address this thing. As I said in my presentation, the world is moving fast, and the necessity of classroom education as we look into today may be reduced, and it will come only to the aspect of where we need our labs and other things for hands-on experience. Okay, so practicals and other things that cannot be done online. Okay, it's impossible to give that flavor of mixing one chemical or the other, or trying to send the current, okay, and by your own hands. It cannot be supplemented, right? So that part has to be there. But yeah, the classes and other things, yeah, near future we can think of in that way. Yeah.
Another question is there, sir. Anonymous, sir, don't you think the youth can contribute much more to science by getting directly involved in the industry rather than just exploring research?
Okay, that's a good question. Actually, I'll tell you how it is. So I will go to the roads for that. Okay, so if you go out to drive in an Indian city, and through the roads you will find different drivers driving in different principles of his own, right? And that's because they did not get a formal education in driving. Okay, and most of them got the driver's license just by chance, right? A proper education is very much necessary to go in the right direction and do the thing properly. Okay, so just going to the industry and getting a hands-on experience can make you a technician, but not a technologist, not a scientist.
Okay, sir, you can ask if any question is.
Yeah, now I'm getting some questions. Yeah.
Okay.
Yeah, there are some questions like why India is so back in the technology.
That I think I described in my
Yeah.
talk. Yeah, we are late in taking up science as a primary source of education, right? So we have to suffer a little, but we are pulling up. Don't worry, we'll come up. Yeah.
Okay, and there
How
is some
SOFC,
subset, how SOFC can be related to the bimetallic particles.
Bimetallic nanoparticles. This is a typical science question. I would encourage you to write to me. I can elaborate it. This is not the right forum actually. So I will elaborate on it. You can write to me. My email address is on the web, so you can just write back to me. Okay. Yeah. I'll write back to you. Yeah. Okay. Any other questions?
Some question like elaborate a little more about the medical tattoos.
Medical tattoos. Okay. Okay. So these are small devices which can the details is not on the web, and I have just got it from some information on the web and not from that field. But yeah, what I understand from it is they have sensors which can sense your body parameters, like maybe your blood sugar level or your blood pressure level or your fever or some other components that are necessary for immediate diagnosis. And this can send the information through some gadget, like maybe your mobile phone or something like that, to a health provider. And then the health provider gets the information, and there's an alarm, some sort of alarm, and then the health provider goes through the report and then sends you something, okay, some remedy. Okay, so this type of innovations are coming up. Yeah.
So another question is, Urmi is asking, sir, being a PCMB student, what are the highly job oriented courses one can take after 12 other than BSc nursing?
BSc nursing, okay. BCMB. BCMB is all open, right? You can do anything you would wish. Okay, so yeah, but it depends on your aptitude, obviously. When I say your aptitude, you have to understand what actually is giving you satisfaction. I tell this to every student actually. So there are lots of avenues. See, if you take a general line, life is a little difficult than an engineering field or a medical field. I understand that, but it is not true that it is the end of life. I am from a general line, and I have gone through all the difficulties, but still I am here giving a lecture to a huge crowd. And I think many of us are from the general line and doing the job of educating people in science. Now, coming to your question, a PCMB can lead you to different engineering field. If you are interested, I think you have taken biology because you have interest in biology. So you can take biotechnology, bioengineering, and then biochemical engineering. All those type of avenues are there.
Another question from Surajjan Nag. Is India looking at change in curriculum to encourage higher studies? Please comment on the present education system and your recommendation.
I can recommend, but I cannot tell about the policy because the policy comes from higher authorities. I am not one qualified one to say that. But yes, obviously I can recommend. Back in US, when I was doing my research associateship, I used to go with, in India, we do not do this, but in the US, they have science packages, okay? And there's science bags, actually. Science bags are general outreach program to the society, okay? So every year, there will be about, maybe every month, there will be 2 or 3 science bags. What these science bags are, they're from different disciplines. One faculty, they will choose one subject, and then they will come up to the society, they will have a big hall, and then the university supports it actually, and they will talk to the people, and that audience is consisting of children from age 4, 5 or 6, and they become accustomed to the different scientific experiments. I remember I took part in one science bag with my superior boss. It was on material science, okay? And what we do, the experiment that I showed here on Messner Effect, we demonstrated in reality taking liquid nitrogen, cooling down the sample, the superconductor, and then putting it on the magnetic field and make it float. And people after the show, they came in like crazy to see the material float in here, okay? So these type of ventures has to be taken by big institutes the government itself, to go down to the village, because I believe in the village there are lots of people, there is lots of merit which are underutilized. And due to proper lack of guidance, they are not being able to come up and provide India with the real richness that it has.
There are a lot of questions.
There are a lot of questions. I believe your talk seems very interesting to the audiences. So what we can request is that we can request to the people to contact directly Professor Sen.
Absolutely, I'm open to questions.
Yeah. Because he
I'm
has
open
been
to questions.
Okay.
Yeah.
So now I request Nikki sir to give a formal vote of thanks, and we can close the session.
Yeah. Okay. So I also really thank you for this mesmerizing talk related to the social sciences in India and the fascinations happening in the science and technology throughout the world, the budgets and all that sort of stuff. You emphasize in a very constructive way to the audiences that they were very much fascinated and are very much eager to ask you ample amount of questions. So I thank you from the behalf of our Oro family, and we definitely like to have your such webinars or say seminars or say personal visits to our visit to our university to have the glimpse of your this science and technology fields and everything. So I thank you once again.
Thank you very much. Thank you all for conducting this. And one message to Oro University on my behalf. I'll feel very happy if Oro University puts a thrust on science and technology and takes research seriously and promotes the same to the Indian population. Thank you.
Thank you, sir.